All right, guys, so this is Coach Lowe, and we are in Chapter 4, Section 2, talking about angles of triangles. The first thing we want to talk about is the triangle angle sum theorem. The triangle angle sum theorem. So if you want to slide an angle in between here, the triangle angle sum theorem says all three angles in a triangle will add to be 180 degrees. And I know you guys have used this before. So if I have a triangle and it's ABC, then I know the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. All right, so let's look at this little problem. It says the diagram shows the path of a softball and a drill developed by 4 players. Find the measure of each numbered angle. So here's the drill. They're softball players at each of these corners, and they're just throwing the ball around. So ball is thrown here, then to this softball player, and then finally to this one. All right, this angle measure is 43 degrees. We know that the measure of this angle is 74 degrees. We don't know these two. This one is 79, and this one is angle 3. So we have to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. So let's see what we know. First, let's focus on this triangle over here to the left. 43 degrees, 74 degrees, and measure of angle 1. I believe we could find the measure of angle 1 by using what we learned just a minute ago, that 3 angles in a triangle had to be 180. And like I said, I know you guys have seen that before. So 43 plus 74 plus something equals 180. Or super quick, 180 minus 43 and then minus 74. So several ways to do this. You can add these guys together and then subtract, or you can subtract them from 180 at the beginning. I'm fine with either, so do what you need to do. All right, so that should be 63 degrees. All right, so angle 1 is 63 degrees. We know that angle 2 is also 63 degrees because angle 1 and angle 2 are what? Vertical angles, and vertical angles are congruent in measure. So now that we have those two, we can definitely put that with 79 degrees and find the measure of angle 3. As we look at this triangle over here to the right, we know that 79 plus 63 plus the measure of angle 3, we'll just call that x, equals 180. So kind of the same thing we were doing just a minute ago, 142 plus x equals 180. Let's go ahead and solve that for x. And so that will be 38 degrees. So the measure of angle 3 is 38 degrees. Triangle angle sum theorem right there at its best. All right, here's our next problem. The next theorem, Theorem 4.2, is the exterior angle theorem. Theorem 4.2, exterior angle theorem. And it says the measure of an exterior angle, so an angle outside the triangle, is equal to the sum of the measures of the two remote interior angles. So if I have a triangle that maybe looks a little something like this, hit it. Oh, sorry, that's something else. All right. C, B, A. If I'm talking about this exterior angle, so the exterior angle there, it is equal to the sum of these two. Now think about that. That makes sense because these two are a linear pair. Those two add to be 180. This angle is the same inside or if you pair it with the outside. So these three have to add to be 180. These two have to add to be 180. This is the one in common. That means this guy on the outside has to be the same measure as the two on the inside. All right, so let's check this problem out. So 2x minus 48 is the exterior angle. Remote interior, which means not touching that one, x and 32 degrees. All right, let's see if we can figure out how to solve for x. We actually want the measure of FLW. We want the measure of that angle, but we have to find x first, so let's do that. All right, so we know that 2x minus 48 plus this angle would be 180, and these two plus this angle would be 180. Therefore, 2x minus 48 is equal to x plus 32. It's equal to the sum of these two remote interior angles. All right, so let's solve this. We'll subtract x from both sides. So going across the equal sign, we're going to subtract, or do the opposite. In this case, it would be subtract. Then we'll take the 48 over here. We're going to add 48 because it says subtract there, so we shall do the opposite. So x equals 80. All right, that's not an angle measure. Well, it is on the inside, isn't it? But we need this on the outside. So we have two options. We can put 80 in here and add to 32 and get 112, or we can put 80 in here and subtract 48 from it and get 112. They're exactly the same measure. So 160 minus 48 is 112 degrees. Also, if I put 80 here, 80 plus 32 is 112 degrees. Check and check. All right, so let's try this one out. There are a couple of other things that I want to tell you about. There are a couple of corollaries to the triangle angle sum theorem or definition. The corollaries are if we have an acute right triangle, or just a right triangle, we know the other two angles are going to be acute. But if we have a right triangle, then the other two angles besides the right angle are complementary. In other words, if this is a right angle, I know all three have to add to be 180. These two guys have to add to be 90. We've already got 90 taken up here. That only leaves 90 left to use. All right. So also, there can only be at most one right or obtuse angle in a triangle. So kind of what I was saying just a minute ago. Of course, these two have to be acute because this is a right angle. So only one of the angles can be right or obtuse, and that's the corollary 4.2. And a corollary is a theorem with a proof that goes with it, and it's a direct result of another theorem. So it's kind of a tag-on, if you want to think about it that way. All right, so last problem here. This is angle 5. This angle measures 48 degrees. This is a right angle. This is angle 3. This one is 41 degrees. This one is 34 degrees. These two guys together are a right angle. This is 4, angle number 4. This is angle number 2 and angle number 1. Now, at a glance, if we just back off of this, we can see several triangles here. I see a right triangle with a missing angle there. I see a linear, a straight angle here, not really a linear pair unless you want to put these two together. But these three have to add to be 180, which means it's not a pair because we just said 3. I have a right angle here with one of the angles measuring 34 degrees as it's cut there. I have a linear pair here. I can look at this big triangle, and I'm thinking if I can find angle 3, I have this as 90 degrees, and I can find angle 4. So just backing off and looking big picture. First, let's find the measure of angle 5. The measure of angle 5 is exactly that corollary not corollary, corollary 4.1 that says if I have a right angle, the other two angles have to add to be 90 degrees. So I know that 90 minus 41 degrees will give me the measure of angle 5. So that would be 49 degrees for angle 5. Perfect. We are on a roll now. All right, then let's check out this linear pair. Well, not linear pair, excuse me. Let's check out these three that add to be 180. Well, we can even break this down even more because if this is 90, then these two have to be complementary, don't they? So the measure of angle 3 is 90 minus 48 degrees, which would be 42 degrees. Awesome sauce. All right, so we've got that one. All right, look at these guys right here. If I can find this angle, then I'll know angle 1 and I can also find angle 2. So there's a bonus. We didn't talk about that just a minute ago. So let's find random angle here. 180 minus the sum of 42 and 34. 42 and 34 is 76. So that would be 104 degrees if I've done my math quickly and correctly. So 104 here, puts that at 104, puts this one at 76. And there's another example of remote interior. We didn't really have to do all that, did we? Because we know that the sum of these two is this one. There's a worked out example of how that works. All right, so next thing we know, these two are complementary. So 34 plus something has to be equal to 90, and that would be 56 degrees. All right, now we know that these two have to add to be 180. These three actually, 56 degrees, 76, and 4. So let's go ahead and get that one rolling. And there are a bunch of different ways to do this, guys, so don't think that that's the only way to do it. Also, these two guys have to equal 104. We've already found that. We know that 56 plus 4 plus the measure of angle 4 has to be equal to 104. So we could use that one. 104 has to be equal to 56 plus the measure of angle 4. I'm going to put an X for that. So 104 minus 56 is 48 degrees. So these three should also add to be 180. All right, guys, that's a lot of good stuff on triangles, and we will talk more when I see you next time. This is Coach Lowe, and I'm out.